Hello, this is Larry Stoll from Pace Turf, and today I want to talk about some winter diseases that we're seeing on bentgrass greens, and we're seeing it in a few locations, so I thought it'd be worth talking about. That good-looking sample on the right is from a nursery area at a golf course that's having a little bit of a problem. So this middle sample is from a medium sort of severity of the disease, and then we'll see on this left sample just coming in that it's pretty severe. I mean, the turf is thinned pretty heavily, and this is showing up after the summer period and going into the winter. If we look at the washed samples and look at the roots, you can see the density in the thatch layer is very dense on the nursery. Not surprising, it's not trafficked or anything. And then this middle sample, you can see the root density is less. And then on the left, you can see that it's really struggling. There's just not a lot of roots, and there's, of course, not a lot of top growth because the roots are bad. So what we wanted to do is take a look at these samples, and you can see the cup cutters have been cut in half. Half of it went to the lab for soil analysis, and this is the half we looked at for disease diagnoses. And you can see there's some pretty severe root damage on the severely affected area, and it's intermediate in the middle one. So let's take a look at what we see under the microscope, so we can try to identify what might be going on with the roots. There was no foliar diseases associated with these samples. And as what we can see when we look at these roots is something that we've had a little bit of trouble getting a consistent ID. The university people say this is might be takeout patch, might be summer patch. We haven't done the DNA work on it, so we're not perfectly sure, but the symptoms are consistent with summer patch with these growth cessation structures, those dark suberized cells, in addition to those ectotrophic hyphae that run along the surface of the root. So there's really, this puts it into basically the Ascomycetes that would be in a group that would include take-all patch and summer patch. So the management are the same regardless of those two diseases. And this is a close-up of the growth cessation structures, and that's how the fungus survives over the winter in adverse conditions. And the dark little strand that you see is the ectotrophic hyphae, which sometimes you'll hear people talk about dark ectotrophic hyphae. So we're pretty sure that was the disease. Cleary's 3336 or thiophanate methyl and QI fungicide azoxystrobin did a good job of controlling it. And so now let's take a look at the soils anyway, because we weren't sure what was going to be the source of the problem. So we looked at both the sufficiency levels of available nutrients and the new minimum levels for sustainable nutrition. And the major cations that we're going to talk about were extracted with melic 3, and you'll see that it's a little bit on the calcareous side, and standard 1 to 2 dilution for pH, and also, well, I guess it's 1 to 1 for pH and 1 to 2 soil to water for the electrical conductivity. So this is the sufficiency levels of 750 parts per million for calcium. We can see that there's plenty of calcium in the system from the standard SLAN requirements, and also even if you look at the low levels and the new minimal nutrition, 330 parts per million, we've got plenty of calcium. Same goes for magnesium, although we're seeing an increase in the levels as you go from good to medium to poor. That's where the location on the bottom. It really shows that there's plenty of nutrition out there, and it's not excessive as far as magnesium is concerned. And sodium, even though we're seeing a relationship between the good, medium, and poor, it's still below 110 parts per million. So we're not seeing what we consider to be stressful conditions, and it's probably just reflecting the age of these root zones. Now, if we look at nitrate nitrogen, there was hardly any nitrate nitrogen, but we do see there's quite a bit of ammonium nitrogen, in particular in the poor side. That probably indicates that there's some decomposition going on, and nitrification is not working too well, but still not enough that we would be really concerned about as far as actually causing the damage that we're seeing. And we got a good response from the fungicide. But this just goes to show that you have to look at the soil sometime just to sort out what might be happening. But we don't think there's a problem here with nitrogen, and there's adequate nitrogen. We'd like to see somewhere around 5 parts per million. Well, when we look at potassium, we see that we have plenty of potassium. Even the good performing area has less potassium. So potassium deficiency is not a problem, and we don't seem to have an excess because we know we can tolerate up to 110 parts per million with no problems. When we look at easily extractable phosphorus, this would be melic 3 extractable phosphorus. We have an abundance of phosphorus, really too much phosphorus. And even the Olsen phosphorus, not shown here, but was up at about 28 parts per million when we only need about 6. So no problem with the phosphorus deficiencies. pH was in a reasonable range from 7 to 7.7, and the intermediate, the medium sample had the highest pH. There was a relationship with sulfur, but those levels are still low, so it's not an excess of sulfur, and it's not a deficiency of sulfur, so there's no problem with sulfur in the system. Looks good. Organic matter is less than 1.5%, so that looks great. Total salinity is way less than 4 decisiemens per meter, so we're under 1. So there's no problem with salts, even though we're seeing a little sulfur and chloride. It's not an issue. In fact, if you look at chloride levels, we can tolerate up to about 400 parts per million without a problem, or 800 parts per million with a combination of chloride and sulfur for bentgrasses. So we're just way below those levels. So we're not seeing any stresses from salts or sulfur or chloride, anything like that. So overall, we didn't see anything in the soils that would give us a suggestion that there would be a problem related to stress. In fact, there was lower nutrition in the nursery area, and that's probably because it was younger and hasn't accumulated that much nutrition. So these samples that you're seeing here are related to the intensity of the summer patch on the bentgrass roots, and as you can see, it pretty well chewed up the roots. And this probably took place during the summertime when soil temperatures were above 65. But once the turf got into the winter, you're starting to see some stress due to cold weather on the bentgrasses that resulted in this type of a decline showing up in the winter. Take a look at the associated information with this video, and I hope you enjoyed this video, and we'll see you next time.